So welcome back. Today it's a review for the cumulative test, and the first thing we got to talk about is real and imaginary roots. If I were to graph this thing, I'd be able to see the real roots. Those spots right there, those would be the roots. Okay, I'm not saying what I just sketched is accurate to the equation here. I'm just reminding you that real roots are places that it touches, and then things that are not real, those are imaginary. The imaginary roots, you can't see them. So like, it could be like this, and you can't say, oh, that's where the imaginaries are. No, not necessarily. It's not the places that, if it doesn't touch the x-axis, then you know you have imaginary roots. All right, so let's move on. How do I get them? Well, you set these equal to, well, I'll give you a reminder. There's 4 names for these things. Roots is one of their names. What's another one of their names? Zeros. Very good. So you set the thing equal to 0. And if this thing equals 0, well then either that equals 0, or that equals 0, or that equals 0. So there's 3 ways to make it equal 0. Can negative x equal 0? Yeah, if x equals 0. Can x squared minus 9 equal 0? Yes. And if you can factor it, you should. X plus 3, x minus 3, and then you'd have a negative 3 and a positive 3 as real roots. Why? Because I didn't ever have to do the square root of a negative. How about this last one? X squared plus 9 has to equal 0, so x squared has to equal negative 9, and right there you should be like, not possible. You can't take anything, square it, and have it equal negative 9. So that one's imaginary. If you just go a little further, you'll see the square root of a negative happen. Oop, there it is. And so therefore, don't forget this is absolute value of x. And then how do you do that square root of negative 9 thing again? 3i, very good. Square root of 9 is 3, and the square root of negative 1 is an I. I'm going to break that into root 9 and root negative 1 to help you see that. That's a 3, that's an I. So then the answer is 2 things. Notice it's squared. There should be 2 answers to that. X equals 3i and x equals negative 3i, so I can say plus and minus 3i. There's a quick reminder of how to do those. So let's go on to a different kind, this kind. By the way, your homework is to do this whole thing. I'm just going to go through and do some with you to remind you how they work. I strongly recommend that you do the ones with me while you're with me. Because I know some of you are like, I can go do part B while he's talking, but then you won't remind yourself how to do 2A. I'm going to move on, and you'll get lost. Okay, so do the ones with me as I do them. So you're not wasting your time to be doing these with me. You're doing your homework. All right. So degree. Degree is just what's the biggest power if it's multiplied all the way out. So like if it was a problem like this, I'd have to actually multiply it out in my head to see what the degree was, which wouldn't be 2 and it wouldn't be 3. It would be degree 5. So if it's not multiplied out, you got to kind of multiply it out in your head. So is this one already multiplied out? Yes, it is, which makes it easier. It's just the biggest one. So that guy's the important term. That's called the lead term. This is the lead coefficient, and that's the degree. Ring a bell? Lead coefficient. This is the whole thing is the term, and that's the degree. So that's assuming it's been multiplied all the way out. So like for instance, that one has not been multiplied all the way out yet. So you can't just say it's degree 3 because that's the biggest power that you saw. You'd have to, in your head, multiply this thing all the way out. So then this x to the 3rd would go with this x to the 2nd, and this 3x squared, and they'd all get multiplied together. So I want to stop doing this, otherwise I'm tempted to just go through and do the whole thing. All right, so what else do you need to know? End behavior. Do you remember that deal where if the lead term here is negative, then it must be going down on the right-hand side? Know what I'm talking about? The end going down if it's negative. Okay, so this one's on the right side. I always do the right side first. I know that's weird. Usually people say from left to right, but I always do the right side first because it's from that negative sign or the lack of the negative sign in the front that I can tell. So this one's down. Then I think of the left side as either the same or different than that. Okay? The left side is either the same as that and also down, or different than that and therefore up. How do I decide if it's the same or different? If somebody can tell me this. You remember, sir?
If the degree is odd or even.
If the degree is odd or even, excellent. In this case, the degree is odd, and therefore
It's the opposite of the root.
it's going to be the opposite. I'm going to sidestep for a second and just remind you how this works. Hold on one second here. So if I had 6x to the 7th plus 5x squared plus 7, is this one up or down on the right? It's up on the right because it's positive. There's no negatives even in the whole thing. But it's mainly this one I'm looking at because that's got the biggest degree. So there was no positive, so it's going, or so no negative, so it's going up on the right. And then is it the same or different than that? Different because this one's odd. Remember that? Okay. That's how you do the end behavior. Next. There's only one like this, so I'm going to go off and do this on the side and show you a one like it because I don't want to do the only one you have. Let's say that you had one like this. And this was at 6, or 5, sorry. This was at 3, negative 3. Do you remember the names for these guys? There's single, double, and triple. You could also call them cut-throughs. Doubles are bounces. And then there was a triple. I didn't give you an example of a triple. Here, I'll make a triple in black here. The triples look kind of like that. And this is a single root. Singles, doubles, and triples. I call the double a bounce, the single a cut through, and the triple I call a snake. That is not a mathematical word, but it kind of snakes through, it bounces, and it just cuts through. Some people call it a pass through. That way for second semester, if I don't have you again, which is going to be sad, I will miss some of you. Some of your teachers will call them pass-through. Some of them won't call it a snake. Doesn't that look like a snake? Okay. All right. Now, the key spot is the number. So if it's at -5, then that's the root. The root is -5. What kind of root is it? Well, it looks like it's bouncing there, so that's a double root. And this one's happening at -1. It looks like it's just passing right through there. Oh, pass through, cut through. Single root. I think you get the idea. All right. Next, I want to go over here to problem 5. I know you're tempted to go keep working on the other one. Please stop. Go to problem 5. They want to know if this is a solution, also known as a root, also known as a zero. It's good to know all those words. Is that a solution to this? Is it a zero? Well, then that means you can stick it in, see if it makes it equal 0. I wish it was that easy for all of these, because if they only asked, is this a zero, a root, a solution, you can just stick it in, see if it equals 0. But usually we use synthetic division so we could factor it. Does that ring a bell? You had to factor these guys. We had to do long division, and we had to do the other kind called synthetic division. So I will set up the, I'm just going to go straight for synthetic because it is easier. Okay, so synthetic, we would just use -3 here, and we'd use all the all the coefficients in order. And if there was any missing ones, how would I know if there's one missing? Well, see, I went from the 4th to the 3rd to the 2nd to the 1st. If there was one of those that was missing, then we'd have a 0 there. And we go 1, 1, -10, -4, 24. Draw the line. Only time I ever quote Snoop Dogg. Drop it like it's hot. And gets multiplied. 1 times the -3, what's that make? -3. And then you add. So if you want to go off to the side, it's multiply, then add. And then you repeat. It's like what they say to do with your shampoo. Wash, rinse, repeat. Wash, rinse. If you actually continue it, just, you go insane. But a lot of people actually didn't know that you don't have to repeat. I'm going to be the first to tell some of you. That wash, rinse, repeat thing, it's mostly there because they want to sell you more shampoo. Think about it. You go through twice as much shampoo if you wash, rinse, and repeat. Do you have to repeat? You don't have to repeat. Now, I know, you're like, easy for you to say, you have short hair, I have long hair. Still true. You don't have to repeat. Now, you can if you want to. Yeah, your hair will come out, even more clean. But really what you're doing when you're cleaning it, you're stripping the oils off of your hair. Geez, I'm recording this. I got to keep moving. All right, anyway, we're going to multiply and then add. And then we're going to multiply 3 times negative, 3 times negative, 2 positive 6. Then we're going to add. And then we're going to multiply. Negative 4 times negative 3, positive 12. Then we're going to add positive 8. Multiply. Ooh, it worked. How do I know it worked? Because I get a 0. That's a remainder 0. Very good. Now, if you were like, I'm not really following because I'm too tired, you've got to go do that again yourself. Because you got to know how to do this 2 days from now. If you were following because you remember this and you're good, then you'd also remember that you can't leave your answer like that. That does not look factored. It's just a jumble of numbers. Who can tell me what the negative 3 actually represents when we're talking about the factors that you get at the end? You seem to be on fire today. Oh, maybe it's finally stumped you.
Is it a solution?
It is the solution. It is the 0, yes. But what I'm trying to say is, if you want an answer that's like this, that's all factored out, do you know what that minus 3 means?
You're going to have x plus 3.
There it is. Excellent. And then I'm going to go back in and put in some things in here. What do you think I'm going to put right there? An x. What do you think I'm going to put right here? An x squared, and right here? X to the third. So that's 1x to the third minus 2x squared minus 4x. And then why didn't this 8 get anything? Because it's called the constant. I could say that I put an x to the 0 there. An x to the 0 is equal to 1, and therefore, all right. Okay. Next, it's saying factor each function completely. Ooh, isn't that just like the last one? Yes, except, wait a minute. They didn't tell me what number goes into it. Okay, question first. Somebody had a hand up. I'll go back. Yes?
Were you supposed to divide and conquer or simplify or answer?
Oh, good question. All right. Technically, I'm not going to go any further on this one because read the directions here. For each function given below, determine if it's a solution. I didn't even need to do that. I just was showing you how to do that. Because technically, we just had to say, yes, it's a solution. It's a 0. It's a root. Okay, but in this section, yes, we would want to go further. And I love that you remember divide and conquer. And you're absolutely right. This would have divided and conquered if I wanted to factor it further. And just a quick reminder, because you'll have to do this later, this assignment, x minus 2. And then this one, negative 4 comes out, and we have x minus 2. And look at that, the x minus 2 is in common. X minus 2 comes out to the front. And then what do I have left? The x squared and the minus 4. And then you still might think you were done, but do you get it factored further? Jameson, I bet you know this one. Tell me what to do.
X plus 2, x minus 2.
Yes, sir. That's that common thing called difference of squares, because that's difference means minus, and those are both perfect squares. There we go. That's a quick reminder of how to do all that kind of factoring. We might need that on number 6, part A. All right. So how do you do this again? They didn't tell me what goes into this thing. Can I divide and conquer it? No, there's an odd number of terms. Now, technically, you can, in weird situations, do something when there's not 4 terms. But usually, we're going to do this when there's 4 terms. So don't do divide and conquer. So what else are you going to do? Well, it's either long division or synthetic. How are you supposed to know what the root is that's going to go out here if I'm going to do synthetic, because that's what most people like to do? How do I know what to put there? Because I know that this is going to be a 1, 1, negative 10, negative 4, 24. How am I supposed to know what goes out there? Well, it happens to be the same one from earlier. So you could cheat and go, it's the same as 5a. So I know negative 3 works. But, reminder, on the test, you'll have a certain piece of equipment. What will you have? Couldn't you have graphed it and then wouldn't it have touched at negative 3? You know what I'm talking about? That's how you can know what that number is. If you graph this, it would touch at negative 3, and so you'd know that negative 3 goes there, and then that's where you'd factor it completely, and we've already done this one up above, so if you took good notes on that, you're already done. You can just put an arrow like this up to your, where you did a good job on that before, okay? So that's a quick reminder of how to do synthetic. Now, I haven't talked about long division. I feel like I should do one with long division for you. So, let's take this one, which is the same as this one. No, it's not. Wait a minute. It's not. Just that one. And I'm going to do long division to show you how to do it. First of all, notice that I changed my 2 to an x minus 2. That's a critical difference. That's called a root. That's called a factor. They're different. Factors are the same as the zeros. Sorry. Roots are the same as the zeros, the same as the solutions, but a factor is not in that list. A factor is x minus the root. This is always the opposite of whatever the root was. Okay, I think I pounded on that clear enough. Now it's x to the 4th. But wait, there's a missing term, Mr. Server. Then I'm going to put plus 0x to the 3rds. Minus 2x squareds. But wait, there's a missing term. Plus 0x's minus 6. I do strongly recommend having those placeholder zeros. It makes your life a lot easier. I did prove to you before break that it can be done without the 0 placeholders if you're really careful about like lining things up underneath each other the right way. But the zeros make it easier. All right, so then you go, what goes on top here? I told you to always start with an x and just see if that works. X times x, that's x squared. That's not big enough. So what should I put up there? X to the 3rd. That way x to the 3rd times the x makes x to the 4th. Now the x to the 3rd times the negative 2 makes negative 2x to the 3rd. This would be where it's really, really easy to forget to change the signs. Do you remember that deal where you go through opposite, opposite? Because now it's positive 2x to the 3rd, not negative, because you have to change both signs. Then you bring something down. Then what do? Got to go back up to the top. Isaac, give me your best guess on what would go here so that when I take it times the x, it'll match up with that nicely. Plus 2x squared. Perfect. Good job. So 2x squared times the x makes 2x to the 3rd. And the 2x squared times the negative 2, that's a negative right there. 2x squared times the negative 2 makes negative 4x squared. Go through and do opposite, opposite. Opposite, opposite. Those cancel. Positive 2x squared. Bring down a 0x. Should I do that? Sure. You can bring down the 0x. It's not going to hurt anything. In fact, that's the right way to do it. Because otherwise things won't line up perfectly. Now, you could, like I told you don't even really need those placeholders. As long as you're careful, you could do it without bringing down the 0x. But, all right, so then I'm going to put a plus 2x. So the 2x times the x makes 2x squared, just like I wanted. And 2x times the negative 2 makes negative 4x. Draw the line. Don't forget opposite, opposite. And I now have 4x, bring down the negative 6. And what, pray tell, am I going to put at the top now? A 4 times x is 4x, and a 4 times the negative 2 makes negative 8. Oh crap. Opposite, opposite, I have 2 left over. What the heck does that mean? The answer to this question, is this a solution to the equation? The answer, no, because it has a remainder of 2. And I know you could have probably earlier figured out that it didn't work, but your proof is the remainder. All right, so it covers a lot. Is that everything? Nope. Luckily, we have a review day tomorrow also. And I'm feeling like that's enough for one day. If I were you, I'd try to get done up through problem 7. There's lots of parts I know, but basically up to there. And I'd say that was a good day, considering you just back from a long break. And you might have questions. I know your worksheet doesn't look exactly like mine. I mean, the problems are the same. Mine are just spread out horizontally. But what I'm trying to say is, your last problem should be problem 7, parts A and B. Now I know this is rough because it's like you're going into the finals. You just had 2 weeks off, and it's hard to get your brain back in gear, but there's no easy way to do that other than jump in. At least I walked you through some. I didn't just say, it's all a review, guys. Good luck. All right. So tomorrow, another review day. The next day, the R2s, the easy ones, of the cumulative test. So we're kind of easy in that way too. And then the following day, the R3s of the cumulative. Okay? So by Thursday, you'll have finished the cumulative test. Then what do? A review for the final. And the good part is you'll have just freshly reviewed these couple chapters. And then obviously we got other chapters before this that we got to go back and talk about. So, all right, that's all I have for the video for today.